I think the topic is fascinating. Obviously, a data conference is a great place to discuss ideas. And you know, since I've been in a startup for a while, I end up speaking a lot with business managers and people who aren't really so data focused and so coding focused. And so it's really nice for me to be in the audience that actually might understand what I'm talking about. It's a pleasure. So I'll describe TagBio as a company and how we got there in the middle of the talk. Our focus is on creating a system so that we can generate new novel discoveries from data. And my experience is that if you leave it to data scientists themselves to be the sole shareholder in the discovery process, then it's severely limited. So we start from this concept about discovery in data as a function of the right knowledge, combining that with the right person. Knowledge might not necessarily be a singular thing. It could be a random variable. It could be many pieces of knowledge, and you know, the right person is not necessarily one person, but it could be the right people. And now you guys are probably familiar with these types of roles in an organization, but it's good to point out the fact that that domain experts like Pep here aren't very good at doing data analysis themselves, but they have a ton of experience and they have a ton of knowledge and they have the ability to come up with insights and ideas. And they tend to work with data scientists who are most of you and myself. The data scientist does not have the dense, deep experience that the domain expert does. Some of them do, but very commonly what has to happen is an interaction between these two parties in order to drive the field forward and come up with discoveries from data. Now there's a huge problem with that, because if you look across an organization or domain, the majority of the people in that organization are domain experts. Now these numbers vary by domain, and it's a sort of a rough estimate, but you can see the sort of the exponential scale that I'd like to show. Some of the domain experts, it's this 9% here, some of them can do some data analysis. They might be able to use Excel, they might know how to write some functions in Excel, they might know SQL, they might be able to configure things for Tableau. And then up at the top there, we've got the people who are data scientists in an organization, estimated around 1%. But they lack domain knowledge, the deep domain knowledge that the domain experts have. The very top of that pyramid, we have the unicorns, and these are the data scientists that are also deep domain experts. And they're extremely rare. Now maybe that's all of you, but you know you're rare. So within an organization or within a field, there's a number of discovery strategies, and I'll talk about 3 of them. A very common one is that an organization can pay a premium to find unicorns, to find domain experts that are also data scientists. There are a number of hazards with this because they're very rare, they're very expensive, and I think the ultimate issue with the unicorn approach is that you leave out many of the domain experts. You know, I came from a field of bioinformatics, and those computational biologists that were doing research sort of lived in their ivory tower, doing their data analysis, coming up with their models, producing their methods, finding new insights in biology, but rarely interacting with the regular biologists. And I think this happens in a lot of fields where the domain expert data scientist tends to sort of hoard their information and hoard their knowledge. You know, there's academic issues with grants and funding and publications and the like. But I still think this happens within organizations as well that are not so academic. Discovery strategy number 2 is to come up with a bunch of rudimentary tools that do basic data analysis, things that you could do in Excel and Tableau. These things are useful when you have very simple questions, you want to do simple counting stats, simple visualizations. dashboard style analysis, which can be quite useful to get sort of the low-hanging fruit from data. However, this still limits the data analysis process to those people who have these abilities. And there are lots of people in an organization. Think about a sports team. You think about all the assistant coaches. You think about all the players. You think about everybody involved in the organization. And most of them don't have the ability to configure dashboards and do analysis in Excel. So the third discovery strategy, which is very common among sports teams, is to have the coaches, have the management and staff go to the data scientists and say, okay, I've got these questions. I want to know, when are we successful? When are we unsuccessful? What is the optimal player alignment, and who should I substitute in when? How should we transfer for different players? How should we replace a player who just got injured? These questions are asked by the domain expert, and they go off to the data scientist. The data scientist finds the necessary data, does their analysis, and returns back to the domain expert with an answer. The issues with that is that the process is very, very, very slow. It can be highly effective, but it's extremely slow because it involves lots of human communication. And human communication can't be automated very well. So the domain expert communicates the problem to the data scientist. There's a lot of discussion about what really the question is. Data scientist comes back with an answer. Data scientists, they work in a serial process. They can work on one thing at a time. They can't work on multiple questions from different domain experts at the same time. So it's quite slow. So now I'll introduce my perspective, where I come from computational biology, and how I've sort of learned things about that field, learned things that are common to lots of domains for data analysis, and then I'll go into our software approach and our architecture for trying to solve the problem of discovery. So a long time ago, when I first started in bioinformatics after undergrad, I worked for this company called Gene Data, and I made these tools that you can see down there for sequence analysis in genomics and looking at comparative genomes, mostly for bacterial research, antibiotics. Then I went and got my master's degree in University of Colorado, where I worked on a number of projects, mostly involving helping biologists process and analyze their own data. So this is the trend, the way I see it. I then went to UCSF, where I worked in the Cancer Center, worked on lots and lots of cool data sets, and developed a software tool called Egan, Exploratory Gene Association Networks. Published a paper, which is sort of the manifesto about that. But the learning about Egan was that if you structured the data in a certain way and you provided a set of tools to a biologist, they could start to do things that only I was doing, or that people that were data scientists, computational biologists like myself were doing. The goal, and I think the goal that, and maybe the big takeaway from the talk, is that everybody should think about how to automate themselves. You can't automate every step of what you do, but you can automate quite a bit. And when you do that and you can empower the domain experts, then good things are going to result. So this is what Egan does as a graphical view. What it does is it finds relationships between genes that are significant from an experiment, and then it has a visualization component where it shows them on a hypergraph where you can see how the genes are related. It brings related genes together semantically. After that, and so it was built specifically for this, but I realized you could show clinical data as well. And so in this situation, the colored circles are not genes, but they're patients in a breast cancer study, and they're associated by the different subtypes of breast cancer that they have. I then started using the same Egan tool to browse my web logs for the people using Egan as a sort of meta-analysis. And then it just sort of snowballed from there. I started looking at media data sets, started looking at social media data sets like Twitter. This is a fun data set that involved UFO sightings. And the takeaway from here is that there's no specific pattern to the UFOs people think that they saw based on their descriptions. After UCSF, I went to work for a startup called IOZD, and IOZD is down in Palo Alto. They have done a great amount of work pushing forward with this technology called topological data analysis. It's a topology-based clustering and representation of points in high-dimensional space. Really fun company to work for, and this is where I started to get away from biology data and started to look at financial data, fraud data, social data, and a lot of sports data. And this is where I started to realize that sports data is not just really cool, there's a lot of people that have interest in it, and it's just starting to explode with the variety and the volume of the data sets. And so there's a huge challenge there, and it's very exciting. So with all of these concepts in mind, I thought that there was a better way to do things, and I thought I had the technological plan to make it happen. So with a co-founder, we created TagBio. Right after the launch of TagBio, I presented at the MIT Sloan Conference on a soccer MLS data set where we started to look at sports as a sequence very similar to the sequences in biology. So once you look at an event, say for example, you could look at a goal or a shot, you could find, if you went back upstream in the event sequence, you could find that there might be players who are involved upstream of that shot that are consistently involved upstream of shots, but they never get on the score sheet. So, you know, typically in soccer, you basically have goals and you have assists. Maybe you start to go beyond that and have key passes. Well, we could go farther back and we could identify players, specifically defenders, possibly even goalkeepers who are clearing the ball, that are creating shots for their team and goals for their team. Most recently, we had a good piece in the Wall Street Journal that highlighted our relationship with AS Roma, where we have been doing data analysis for them. And I can discuss more of that offline. I'm not going to discuss too much of that on the record. So that's my background. Going back to this process of discovery, that you need to get the right knowledge in the brain of the right person. So how would we generate the right knowledge? We need to increase the number and the diversity of the data sources, make them accessible as API, and have a browser that people can use very easily to ask and answer questions. And we see this ultimately in terms of a pattern that's very similar to the beginning of the World Wide Web. So previously, prior to the World Wide Web, you would have a machine that would have information, and in order to connect a person with that information, you had to have a specific transfer protocol, and you could basically only use that one protocol to connect to that set of information. What the World Wide Web did is it allowed anybody to set up a web server, and anyone who had a browser could connect to any one of those web servers, and vice versa. Anyone who had a web server was now opening their data to anyone who had a browser. So this is a fundamental concept that I think needs to push forward with regard to data, to make data accessible via API, a consistent API that a lot of people have a browser for. This is our technology stack, and the rest of the talk is going to focus on why we designed the stack in this way. This is ultimately a software architecture talk. So what we have is called a dataset hypervisor. That sits on top of a dataset. The data is at the bottom, and it can sit on top of any dataset and present that data as an API. We have 3 SDKs. We have an SDK where you can configure different types of datasets for the hypervisor. We have an algorithm SDK where you can configure and implement different algorithms that will run on the data. And then most importantly, on the left side, we have a protocols SDK. And what a protocol is what I'm going to go to next. This is a way for a data analyst to configure queries into the system that are specific to each data set. Overall, on the macro scale, this is what our system looks like. So on the top upper left, you have the process of the person to configure a data set and develop protocols using the SDK. They can either spin up a private server, so then they can have exclusive access to that, or they can deploy their dataset hypervisor to the cloud, where it's then accessible by anybody with a browser. Okay, back to the hypervisor. So the the protocols SDK, what it does is it allows somebody to work within our system, and if they make one protocol, they plug it into the system, this analysis module, then they basically get a full stack of software without having to write it. So we can make it so that big data experts can work on the data SDK side. Algorithm people, data scientists, can work on the algorithm SDK side. And an entirely different set of people, hopefully a much broader set of people, can start to work on protocols. So what is a protocol? As a big picture, a protocol is a way of defining a specific analysis or a common statistical query. And I realized as we were developing this that there isn't a very good set of language around how to do statistics and this data analysis from a very high level. So very commonly what you might want to do is a sort of two-sample comparison where you might want to say, what does this team do differently when this player is in the game? And so as a data scientist, what you would do is you go back to the data, and if you have event level data, you would define a background set. And the background set would be all of the events for that team. The focus set would be those events where that player is in the game. And so that is the fundamental concept behind most of our analyses at the moment, where you have to define a background, which is the right things to compare to, and you have to define a focus, which is the things you really want to drill in on and say, well, what's special about this set? What's special about when Arsenal, for example, has Cazorla in the game? What you do then is you then can say, I want to analyze all the variables in the data set, and I want to analyze all the variables combined in two-way combinations, and it will go out and in a univariate way will find all of the significant associations and correlations, and then return the most significant results to the user. I'll show an example of that. Protocols are defined in JSON. It's a nice web standard. It allows very easy API integration. And you can see here that if you look on the right side, this is a zoom in on the significant part of the protocol, that we have a method at the top, which is a tag comparison. We have the variables that this protocol is going to analyze. And then there's a block for the background and a block for the focus. So what this specific protocol does is it defines a background of a pitcher, a handedness of batter, some clarifications about not allowing intentional balls or pitch outs. So the background is all of the pitches for a given pitcher against a given handedness of batter. And then what we're going to focus on is a specific count situations and runners on base situation. So this protocol will ask, for this pitcher against a certain handedness of batter, what pitch types do they throw when there's, for example, 0 balls and 0 strikes? So what are they going to throw in a 0-0 count against a right-handed batter compared to all of their pitches against a right-handed batter? So this is a way of formulating a query without having to structure the data, without having to know which statistic to use. And by eliminating those two things, we eliminate the majority of all programming that someone might have to do. And the goal is that this could be more accessible to people. They don't have to be trained in statistics, and they don't have to be trained in data processing and munging. I can discuss this more if you guys want to talk to me after the talk. We have a number of methods. We have categorical level analysis. We have two-sample numeric comparisons and correlations. We have advanced methods that involve clustering and finding nearest neighbors. This ends up being highly useful in sports data, and I don't think it's done nearly enough by anybody. I think once you start clustering players by either their positioning or their playing styles, and this is a lot of work that I was doing at IOZD, you start to find some very significant patterns, and you realize players are completely different than what you thought they were. Okay, so that was about finding the right knowledge and generating the right knowledge using data analysis. Now we have to try and find the right person to give that knowledge to. And I love this quote. Ratatouille is one of my favorite movies, but it says, not everyone can become a great artist, but a great artist can come from anywhere. And we have that philosophy towards data analysis. We think that anyone could be a good data analyst. They don't have to necessarily know programming, they don't necessarily have to know statistics, but if you give them the right information, they can come up with the ideas. And so how do we try to do that? Well, we we know that not everyone's going to be able to write a protocol because that involves syntax and typing. And there's that huge majority out there who don't want to flip up a laptop and have to write in a code editor. So we've developed point-and-click clients that run the protocols. And one of the clients is on the left side. That's a site called Next Pitch, which was a prototype microsite we built, which actually ran in real time to run the real-time situation statistics in baseball and to have it access the different protocols to predict pitch type, pitch location. On the right side, we have the more historical system, which is our beta client. You can go to beta.tag.bio and use it, and you can run this exact analysis. And what this shows is the result of that protocol that I described earlier, which says for Madison Bumgarner against right-handed batters, which pitch types is he more likely to throw on a 0-0 count compared to all of the pitches against right-handed batters. I think this also has empty bases. We have visualization components. We have started to work on more and more visualization. Heat maps are very important when you have spatial data, and so we have lots of examples of that. Just to describe what the results of that statistic were, it shows that against right-handed batters, he throws a fastball 45.5% of the time. 0-0 count with nobody on base, he throws a fastball 56.7% of the time. And he's less likely to throw a slider in that situation. We have lots of data sets that are publicly available, many, many more that are exclusive to the customers that we're working with and the organizations. The point-and-click client operates this way. Once you've picked a data set, then you pick a protocol. And for Madison Bumgarner, you can see we have lots of different types of protocols. Now that there's interleague play, just about he's a National League pitcher, so he's going to hit anyway. But even American League pitchers now have some batting statistics due to interleague play. So this one, I chose the pitch type advanced protocol. And so on the left side, the user interface, you can see it's very small. It's a mobile-first design. Once we've chosen Madison Bumgarner, you can choose the batter hand, you can choose the number of balls and strikes. You hit run protocol, and you get to the larger panel that's on the right, and then that's the result that I showed earlier. So to be able to ask that question, it's just a few clicks. And then finally, to engage the most people that we possibly can, because we still have found that, okay, you have a certain percentage of people that could write a protocol. You have a much larger percentage that would be able to run this protocol from the client, but there's still some people that aren't even going to be able to do those clicks. They're just going to want the answer. They're going to want someone to do this for them and say, give me the answer. That's pretty common in sports. And with that, we have the publish option. So once you've done an analysis, you can pick things that are interesting. You can annotate it as a report, and then you publish it to the site. So you either publish it publicly to our public site, or for a different organization, they would have a private instance, and everything there would be published to their private site. And there you can describe it. We're eventually going to have collaboration communication tools. One of the really cool things for me that I tried to make sure we had from the very beginning is the ability to rerun the analysis. So you can see at the top there, you can hit the rerun button, and that will bring the user back to the configuration page where they can just automatically rerun the analysis, see all the original results, or change the pitcher or change the count. They can basically say, I want to do something like that for Clayton Kershaw. And so they can do that very easily. That was something that in working with sports teams, we found that teams were very interested in having that rerun capacity where they could say, all right, well, I want you to do this analysis for this next opponent that we have. And we would say, oh, it's really easy. Just hit that button. And it's done. Back to the problem, where the data scientists that are domain experts are very rare, and the majority of all the people, these people that could be finding insights in data, they could be doing data discovery, they're left out currently. So what we try to do is we take that 9% that could be doing Excel functions, and maybe they know SQL, and what we're going to do is we're going to empower them to write protocols. So the ability to do data analysis is now increased from just the people that were data scientists, so from about 1% to about 10%. And then we're going to enable this new class of domain experts who weren't necessarily very technical, but they know how to use their phone to point and click to do data, to check their email or check Facebook. If they're comfortable enough with that, then they can run the analysis modules, which will generate knowledge. And so that's a huge increase in the amount of people that can actually run the analyses. And then finally, there's the remaining people who are still too stubborn to do any sort of pointing, clicking on their phone or bringing up their computer to run software. But they can still participate because they can be involved in the reporting process, and interesting insights that other people have found can be shared with them, and they can start to collaborate and communicate with those ideas. So the whole goal is trying to get everybody in the organization involved with data analysis and not just keep it up in the ivory tower where the data scientists, where we all live. And then finally, return to the, our thesis. And with that, I can take questions.
Okay, great talk by Jesse. Has anyone got any questions? So while we wait, so I have the first question. So I really like this idea. I think this is where we need to go in terms of human-centered computing. So if we flip the question or flip the idea that, you know, currently we think data scientists should be within these sporting organizations. If we do our job properly, how long do you think it will be until we get to the stage where teams don't need data scientists because technology is there and they're their own data scientists? So what range of time do you think we are from that?
So I think part of it has to do with available commercial software that's out there and how useful that can be to someone who's not a data scientist. Can a coach use an entire, you know, a one-size-fits-all system? You know, is that Opta, is that Prozone, is it Instat, you know, any number of these softwares, are they good enough and can they be made well enough to do that? Ultimately, I think teams want exclusivity, they want competitive advantage, and so they're not terribly excited about using the same system that everyone else has access to. So I think there's always going to need to be custom work, specifically around the area of healthcare for the players, trying to prevent injuries and trying to optimize the training regimens. You know, that sort of data ends up being custom for the team, and I think that's where data scientists will always need to help out. But ultimately, I think there's going to be a hybrid for a long time, and data scientists will never leave. I mean, there are too many really interesting questions that people will have that ultimately even our system won't be able to answer, and there's a lot of R&D that teams will hopefully still invest in, I suspect, yeah.
Great. Someone had a question in the front? Isan? Yep.
So once you have the ability to rerun these analyses, maybe change a few things and tweak them, you soon get this issue where you have just so many different meta-analysis and someone could be redoing work that someone else did that could be published, could be found. Is that something you're coming up against where, you know, it's sort of this, the amount of reports being generated need to be accessed and managed in a responsible way in order to reduce redundant work and stuff like that? Or is that still sort of far away and that you're not worrying about it?
I think it may be a problem in the future. It hasn't been a problem yet. We have been considering options about looking at, you know, I would say like MD5 hashes of reports, you know, retaining a whole ledger of analyses that were run, and if someone had run it before, just, you know, redirecting someone to that. Looking at blockchain ownership of intellectual property that might be developed. These are all nice future ideas. Thanks.
So does anyone up the back have any questions? Sorry, the polls are in the way, I can't really see. No, so we're right on 12 o'clock, so I think everyone's getting hungry and, you know, chasing some food and coffee. Jesse's going to be around for the rest of the day, so feel free to grab him and chat. And so let's thank Jesse again for a great talk.